Hey everyone, today we're counting down the top 15 most unusual engineering projects ever conceived. They stand out not just for the scale, but for the bold departure from traditional engineering concepts, challenging norms of what can be built. Let's start with number 15, the Grand Junction 100-inch engine by Harvey & Company. So starting this list is a historical marvel, the Grand Junction 100-inch engine, constructed by Harvey & Company of Hale. This highlights 19th century ingenuity. This is a massive steam engine, standing 100 inches tall, and it was designed to power the Grand Junction Waterworks Company in London. It played a crucial role in supplying clean water to the growing city. The engine's immense size and power were necessary to meet the high demand for water in the rapidly expanding metropolis. The engine's design was innovative for its time. Harvey & Company were known for their expertise in large steam engines, meticulously planned and executed this project, so its powerful steam-driven pistons generated significant force, driving the massive water pumps. This allowed for the transportation of vast volumes of water, transforming the lives of millions in London who gained access to a reliable source of clean water. The engineering principles behind the Grand Junction 100 were groundbreaking. Its designers employed advanced techniques, making it one of the most advanced steam engines of its era. It marked a significant advancement in steam technology, setting new standards for its power and efficiency. Though no longer in active service, the Grand Junction 100-inch engine remains a symbol of industrial progress and capabilities of 19th century engineering. The achievements of this engine continue to inspire people, leaving a lasting impact on the world of engineering and beyond. Number 14, MRI machine. MRI machines revolutionized medical diagnostics, providing invaluable insights into the human body. Now, MRI, or magnetic resonance imaging, uses magnetic fields and radio waves to produce detailed images of internal structures, aiding in the diagnosis and treatment of a wide range of medical conditions. At the core of an MRI machine is a large cylindrical magnet that generates a powerful magnetic field. Patients lie on a movable table that slides into the machine's opening. The magnet aligns the protons in the body in a specific direction, and when radio waves are emitted, these protons absorb energy and release it when the radio waves are turned off. Sensitive antennas detect those signals, which are then processed by a computer to construct detailed images of the body's internal structures. The resulting images provide a comprehensive view of tissues and organs, allowing healthcare professionals to identify abnormalities, evaluate injuries, and assess disease progression. MRI scans don't involve exposure to ionizing radiation, making them far safer for patients, particularly those who require multiple imaging sessions. MRI machines offer exceptional image quality and resolution, enabling healthcare professionals to visualize minute details and subtle changes in tissues. This precision allows for much more accurate diagnosis and treatment planning. Despite some limitations, such as the need for patients to remain still during scans and the ineligibility of individuals with certain metallic implants, MRI machines are an indispensable tool in modern healthcare. Number 13, suborbital travel. Suborbital travel is an exciting frontier in aerospace technology. Now, this type of travel takes passengers up to 100 kilometers above the Earth, offering a brief experience of weightlessness before returning. While not reaching the height required for full orbit, suborbital travel provides a unique opportunity to experience space. Companies like Virgin Galactic and Blue Origin are at the forefront of developing suborbital spacecraft. These craft are designed for both tourism and potential point-to-point transport. A suborbital flight could drastically reduce the time between distant locations. For example, a flight from Tokyo to New York could take just a few hours instead of the usual 14. The technology behind suborbital travel involves launching a spacecraft to the edge of space, where passengers can experience a few minutes of weightlessness before the craft descends back down to Earth. The experience is facilitated by powerful rockets and innovative engineering that ensures safety and comfort of passengers. While suborbital travel is not yet practical for everyday use due to its high costs and safety concerns, it holds significant potential for the future. The rapid advancements in this field could eventually make space travel accessible to the public, offering a new way to travel long distances quickly and efficiently. The ongoing development of this technology continues to push the boundaries of what's possible in aerospace engineering. Number 12, nuclear power plants. So, nuclear power plants are among the most powerful engineering feats in the world, harnessing the immense energy released by nuclear fission to generate electricity on a massive scale. These technological marvels are a cornerstone of the global energy landscape, providing a reliable and sustainable source of power. The power of these plants lies in the process of nuclear fission. Inside the plant's reactor, uranium or plutonium atoms are bombarded by neutrons, causing a chain reaction that releases a vast amount of energy. This energy then heats water, producing steam that drives turbines to generate electricity. The energy produced through nuclear fission is unparalleled, enabling plants to produce gigawatts of electricity continuously. Nuclear power plants are very efficient, with a single kilogram of nuclear fuel producing millions of times more energy than an equivalent amount of coal or oil. This efficiency ensures that nuclear power plants can operate for extended periods without frequent refueling, enhancing their viability. In terms of environmental impact, nuclear plants produce virtually no greenhouse gases during operation, making them critical in the fight against climate change. Their low-carbon emissions position keeps them as a key component of clean energy transition, and additionally, extensive safety measures such as redundant systems and containment structures mitigates potential risks and ensures the protection of workers and the public. Beyond electricity generation, though, nuclear plants drive innovation in nuclear science and engineering. They contribute to advancements in materials, reactor designs, and waste management, supporting the growth of the nuclear industry as a whole and paving the way for safer and more efficient technologies. Despite some challenges, nuclear power remains a vital and powerful component of the global energy landscape. Number 11. Large-scale 3D printers. Large-scale 3D printers are transforming the manufacturing industry with their ability to create complex, customized, and large objects with precision and efficiency. Unlike traditional manufacturing methods that rely on assembly or subtractive processes, 3D printing builds objects layer by layer from digital models. These printers can produce a wide range of objects, from furniture and architectural structures to automotive components and aerospace parts. The precision and accuracy of large-scale 3D printers comes from advanced technologies such as selective laser sintering (SLS) and fused deposition modeling or FDM. These techniques allow for creation of intricate geometries with tight tolerances and exceptional surface finishes. One of the significant advantages of large-scale 3D printers is the reduction in time and cost compared to traditional manufacturing. The additive process eliminates the need for extensive tooling and manual labor, reducing production lead times and labor costs. Additionally, the ability to create objects with minimal material waste enhances sustainability and cost-effectiveness. Large-scale 3D printers also offer unparalleled customization and flexibility in manufacturing. They can produce unique designs tailored to specific requirements, enabling industries to create one-of-a-kind products, prototypes, and even patient-specific medical devices. This versatility fosters innovation, and it accelerates product development cycles. Overall, large-scale 3D printers are revolutionizing how we design and manufacture objects, providing new opportunities for creativity and efficiency in various industries. Number 10. Jetpacks. Alright, jetpacks. They've long captured our imaginations, and they're often seen as a symbol of futuristic technology. Using jets of liquid or gas, jetpacks propel the wearer into the air, where they're kept aloft by either a jet engine or an electric fan. These devices have handheld controls, making the experience akin to flying like a superhero. Jetpacks use vertical takeoff and landing or VTOL technology, allowing them to take off and land in small spaces, making them really useful in urban areas. Initially developed for military stunts, modern jetpacks are available for recreational use too and have practical applications in firefighting and search and rescue missions. The technology behind jetpacks involves complex engineering to ensure stability and control while you're flying. Despite their appeal, though, jetpacks do face some challenges such as some safety concerns, limited flight time, and very high cost. However, ongoing advancements in the field continue to push the boundaries of personal aviation. Jetpacks, they represent a fascinating blend of science fiction and reality, offering a glimpse into the future where personal flight could become a practical mode of transportation, and that'd be great. Number 9. The Great Wall of China. The Great Wall of China is one of the most iconic and recognizable man-made structures in the world. It was built over several centuries. The wall was constructed to protect China's northern borders from invasions. Stretching over 13,000 miles, it consists of walls, towers, and fortifications built by different Chinese dynasties between the 7th century BC and the 16th century AD. The wall was made using various materials, including brick, tamped earth, and stone, and was designed to be easily defended against invaders. Despite its name, the Great Wall is not a single, continuous wall, but a series of interconnected walls and fortifications built up over time. Some sections of the wall are well preserved, while others have deteriorated. Today, the Great Wall is a UNESCO World Heritage Site and a major tourist attraction, drawing millions of visitors each year. It symbolizes China's rich history and their remarkable engineering capability, showcasing skill and dedication of these ancient builders. Efforts to preserve and protect the wall continue, ensuring its legacy for future generations. Number 8. The Hyperloop. First proposed by Elon Musk in 2013, the Hyperloop is a high-speed transportation system consisting of tubes or tunnels through which specially designed pods travel at incredible speeds. These aerodynamic capsules, designed to carry passengers or cargo, use linear induction motors and magnetic levitation to move through the tubes. Now, the Hyperloop aims to be fully autonomous, with an onboard computer system controlling its efficiency and its safety. By reducing the air pressure inside the tubes, the Hyperloop minimizes air resistance and it increases speed, potentially reaching speeds up to 760 miles an hour. This could significantly reduce travel time between cities, making it a game-changer for businesses, commuters, and travelers. The Hyperloop's advantages include high speed, efficiency, and environmental friendliness. A journey from San Francisco to LA, for example, could be reduced from 6 hours by car to just 30 minutes. Well, however, several challenges do remain, including its design, safety, and cost. Despite those hurdles, though, the Hyperloop does continue to generate some excitement and interest worldwide, representing a potential revolution in transportation. Moving on to number 7, the Amsterdam Canal Ring. The Amsterdam Canal Ring is a system of interconnected canals and waterways constructed in the 17th century, and now a UNESCO World Heritage Site. This iconic feature of Amsterdam played a key role in the city's development and its identity. Built during the Dutch Golden Age, the canals facilitated trade and commerce and served as a defensive barrier. The canal ring's unique design includes concentric rings radiating from the city center, lined with elegant townhouses and warehouses dating back to the 17th and 18th centuries. The canals also feature numerous bridges, including iconic drawbridges still in use today. And today, the Amsterdam Canal Ring is one of the city's top tourist attractions, offering a unique perspective on the city's history and its architecture. Water taxis and canal cruises provide convenient transportation, while efforts to reduce pollution and improve the health of canals do continue. The Canal Ring, it symbolizes the city's ingenuity and its creativity, showcasing an enduring appeal of its historical and engineering achievements. Number 6. VTOL vehicles. Vertical takeoff and landing, VTOL. These vehicles combine the efficiency of a fixed-wing aircraft with the flexibility of helicopters. These vehicles can take off and land in small spaces, making them ideal for urban areas. VTOL technology is used in various applications, including emergency medical transport and some stylish commuting. Common VTOL vehicles include multi-rotor drones and tilt-rotor aircraft. Now, multi-rotor drones, such as quadcopters, are often used for videography and photography due to their size and agility. The tilt-rotor aircraft can operate like helicopters or fixed-wing craft, tilting their rotors for vertical takeoff and landing. The military uses them for transport and surveillance. eVTOL, or electric VTOL aircraft, are an environmentally friendly option. Powered by electric motors, they're cleaner, quieter, and potentially more efficient than traditional VTOL vehicles. So, VTOL technology, it represents a significant advancement in aviation, offering a new possibility for transportation in urban environments. I can't wait to have my own flying car. Number 5. Autonomous vehicles. Autonomous vehicles, or self-driving cars, navigate roads and avoid obstacles using cameras, sensors, and AI without human intervention. These vehicles are constantly evolving with technology in continuous development. Some can even communicate with other autonomous vehicles to avoid collisions and traffic congestion. These autonomous vehicles do hold promise for the elderly, disabled, and others unable to drive, enhancing their independence and their freedom. However, they also pose some challenges, such as job losses for drivers and cybersecurity risks. Ethical and legal issues surrounding accidents and responsibility also need to be addressed. But despite these challenges, autonomous vehicles that have the potential to transform transportation will eventually offer safer and more efficient travel options for all of us. Number 4. The Panama Canal. The Panama Canal is one of the most impressive engineering feats in the world. This 50-mile-long waterway connects the Pacific and Atlantic Oceans, allowing ships to bypass the treacherous waters of Cape Horn and the Drake Passage. It was constructed over 10 years, from 1904 to 1914. This canal has become a vital trade route. Before the canal, the ships had to sail around South America, a dangerous journey that took weeks, and the idea of constructing a canal across the narrow isthmus of Panama had been discussed for centuries. But it wasn't until the late 19th century that the technology and funding became available. The construction required excavating over 170 million cubic yards of earth and installing a complex lock system to raise and lower ships. But eventually, the canal opened on August 15, 1914, and it quickly became a major trade route, allowing ships to travel between the Pacific and Atlantic Oceans in a matter of hours. Today, the canal handles more than 5% of global trade, serving as a vital lifeline for the economies of many countries. The canal continues to play a critical role in global commerce, making it easier and safer for ships to travel between the Pacific and Atlantic Oceans. And despite its age, the canal remains an important trade route, demonstrating the lasting impact of this remarkable engineering achievement. Number 3. Flying cars. Flying cars, yeah, my favorite, also known as personal air vehicles or PAVs. They've long been a staple of science fiction. These vehicles use VTOL technology to take off and land vertically, allowing them to avoid any traditional road traffic. Now, unlike movie depictions, modern flying cars are designed more like small planes or drones. Flying cars, they combine propulsion systems with hydrogen fuel cells, sensors, and safety features, plus navigational systems. They promise to eliminate road-related issues such as traffic jams and accidents. However, widespread adoption faces some challenges like infrastructure changes, new regulations, and safety concerns. But despite those challenges, flying cars represent a potential revolution in personal transport, offering us a glimpse into the future where road travel could be significantly reduced. Where we're going, we don't need roads. Number 2. The Pyramids of Giza. The Great Pyramids of Giza, located on the outskirts of Cairo, Egypt, are amongst the most impressive man-made structures in the world. They were built over 4,500 years ago. The pyramids demonstrate engineering skills of the ancient Egyptians. The Great Pyramids consist of 3 main pyramids: the Pyramid of Khufu, the Pyramid of Khafre, and the Pyramid of Menkaure. The largest, the Pyramid of Khufu, stands over 480 feet tall and was the tallest man-made structure for over 3,800 years after it was built. These pyramids were built as tombs for the pharaohs using millions of limestone and granite blocks. Now, despite their age, the pyramids have withstood the test of time, thanks to the skill and precision of these ancient builders. The pyramids were constructed with a high degree of accuracy, aligning with the stars to ensure their durability over millennia. Today, though, the Great Pyramids of Giza remain a hugely popular tourist attraction, drawing visitors from around the world who just come to marvel at their scale and the engineering feats involved in their construction. The surrounding area, including the Sphinx and other ancient ruins, provide an additional glimpse into the rich history and culture of ancient Egypt. The pyramids, they continue to be a source of fascination and study, revealing insights into the capabilities and the achievements of one of the world's earliest civilizations. Number 1. The Large Hadron Collider. The Large Hadron Collider, the LHC, it stands as one of the most remarkable scientific endeavors of our time. It's located beneath the Franco-Swiss border near Geneva, Switzerland. The LHC is a particle accelerator that has revolutionized our understanding of particle physics since its inauguration in 2008. The LHC is a 27-kilometer-long underground ring designed to accelerate subatomic particles, primarily photons, to nearly the speed of light. These particles then collide, recreating conditions similar to those just after the Big Bang. This allows scientists to then study fundamental particles and the forces that govern our universe. The LHC consists of superconducting magnets cooled to near absolute zero, creating a state where they exhibit zero electrical resistance. This enables efficient particle acceleration without excessive heat or energy loss. Now, dipole magnets keep these particles on a circular path, while quadrupole magnets focus the particle beams to increase the collision density. One of the LHC's most significant achievements is the discovery of the Higgs boson in 2012, a particle crucial to our understanding of how other particles acquire mass. This discovery earned Francois Englert and Peter Higgs the Nobel Prize in Physics in 2013. The LHC, it continues to be a vital tool in advancing our knowledge of the universe, and it drives innovation in technology and engineering, and it contributes to developments in the fields ranging from material science to computing. The work done at the LHC exemplifies the pursuit of scientific knowledge and the power of collaborative research on a global scale. Thanks for watching, everyone. I'll see you next time. Thank you to our channel members.